All right, greetings everyone. Welcome to the second part of the video for section 6.2. We'll be continuing on with our study of the graphs of the other trig functions, so beyond sine and cosine. Okay, so what we're going to look at now are the graphs of secant and cosecant. And for this part, I'm going to use a graphing calculator. And pull up a graphing calculator app. And I apologize, in videos prior to this one, I know I talked about using the graphing calculator, using your calculator for things, but then didn't show how to do them. I was waiting to download a version of this software that will allow me to show things. Okay, now the first thing that we need to make sure for our calculators before we start graphing things is to make sure that they're in radians mode, because we're going to use radians to graph all of our functions. And to do that, we first need to change the mode of our function into radians, or check that it's already in radians mode. And so to do that, we're going to click on this button right here that says mode. So I'll go ahead and do that. And once you do that, you'll hopefully see over there on the right how it pulls up a bunch of different options. We're going to go down, so use the arrows to go down to the line that says radians or degrees. And you'll want to make sure that radians is highlighted. If it's not, so let's say degrees is highlighted, well, you'll kind of do the opposite of what I just did. So you want to arrow over to radians, hit enter to get it highlighted. Okay. Once we have that, we're going to hit the y equals button here. And we're going to graph cosecant. And you may notice that when I look at the buttons on my calculator, especially if you're using a TI-84, there's no sine, cosine, or excuse me, no secant, cosecant, or cotangent button. So we have to use something else to graph those functions. Now, if you're using a TI Inspire, or if you're doing this on Desmos, then you can just type in cosecant or secant or cotangent, or the Inspires have an option for those functions. So what we're going to have to do then to graph the cosecant function is actually use the identity for cosecant, which we know is 1 divided by sine. So I'll do 1 divided by sine, then we need to hit the button that has the variables, so the x right here. So we'll click that and close our parentheses, so we have 1 over sine of x. And then I'm actually also going to graph sine together with cosecant. So I'm going to put a sine of x down here. And the reason I'm doing that is because we're going to be able to see a relationship between the graphs of these two functions. Okay, now next, before we actually look at the graph in the graphing window, I actually want to set our window so we can see it in terms of trig functions. So I'm going to hit that button I just circled. It says window. And first of all, because we're going to be working in radians, I want to change my x values, so the values along the horizontal axis, to be radian values. So I'm going to do negative, instead of -10, I'm going to change the lower value for on the horizontal axis to -2, and then pi. And pi, the pi button is right here on this caret. So to hit that, we hit second, and then that'll put a pi in for us. I make my x max 2 pi. And then you may remember that when we graphed sine and cosine, we had the, rather than counting by 1s or 2s, we actually counted by pi over 2. So I'm going to do that here. Okay. And then you may remember that the, for sine and cosine, if they were not transformed, they oscillated between the values of -1 and 1. So we don't really need to go all the way up to -10 and positive, or yeah, all the way down to -10, all the way up to +10 on our vertical axis. So I'm going to change my y min to -4, my y max to +4, and we'll leave the scale at 1. Okay, so make sure you have your calculator set like this. And then we can go ahead and hit the graph button, which is right here. And so when we do that, then we get The blue there, that would be the cosecant function. And then the red there, that is the sine function. So let me go ahead and label those. Not like that, there we go. So again, the blue here, that's going to be, I'll call it g of x equals cosecant of x. And then the red function there would be, I'll call it f of x equals sine of x. Okay, and hopefully you see that there is some relationship between the graph of cosecant and the graph of sine, right? And the first one, or most notable one, would be where their peaks and valleys are, right? So notice that the peaks on sine kind of match up with the valleys of cosecant, and the valleys of sine match up with the peaks of cosecant. And that's useful because that kind of gives us a template on which to build the cosecant function if we have to graph it. I also want us to notice that with sine, with an untransformed sine function, notice that the first peak is off of the vertical axis. And then we see that with cosecant, its first little piece there is off of the vertical axis. And so that's going to be important because that'll be different when we graph secant. Okay, next thing I'm going to do is label my axes so remember what these values are. So remember, this is negative pi over 2. This is negative pi, and we continue counting on by negative, or pi over 2 there, and we also go up. This is pi over 2. This is pi. We can go on from there. And we use this information to talk about the domain, the range, and the period for cosecant. So let's start with the domain. Or actually, we'll come back to the domain. We'll go with the range. Okay, because that's going to be a little bit easier. So remember, range is values covered on the vertical axis. And notice we see that from these valleys, the cosecant function seems to go up and up forever and ever. And from these peaks, it seems to go down forever and ever. But there's kind of that break in between each of those pieces, right? And if I take out, I'm going to turn off the sine function for a second. So I'm going to do this so we only see cosecant. And so notice that values in between the peak and the valley, so in between here, okay, are not included in the range. So what that tells us then is that the range of this would be, well, negative infinity, because again, we have these arrows going down. But then the function comes up and up and up and up and stops at this value up here. And what is that value? If you recall on the way that we set up our vertical axis, that's at -1. So we see it goes from negative infinity to -1, and it actually includes -1. Then it gets unioned with the function starting at +1 up here, and then going up and up forever and ever. So we see that our range for cosecant would be 1, infinity. Okay, and again, the 1 is included because it passes through that point. All right, what about now the period of cosecant? Well, remember, period is the distance over which we see the pattern repeat. And we have to be careful here with what that distance is, because sometimes when I ask this question, students will tell me it's pi, because we see the distance from here to here. And let me highlight that. There we go. From here, between here and here, one of those little humps is a distance of pi, right? It's from -pi to 0. But remember, period is the distance over which we see the same pattern repeating. So if we go another pi after that, so between this vertical axis and this point, there's another one of those little U-shapes, but notice it's not the same one, right? It's going up this time. So it's actually not a repeat of the same pattern. We don't get that until we get to this piece over here on the right. So it looks like the distance for one period is going to be between this first vertical asymptote here and this one here, which goes from negative pi all the way to positive pi, which if you measure that out, that's a distance of 2 pi. All right. Now, last thing, the domain, which again for this function is a little funky. So first of all, you notice there's those vertical lines that I just drew in. I know I deleted them, but I did that for a reason. As it turns out that those are, again, vertical asymptotes for the cosecant function. Okay, so we see that, like with the tangent function, there are breaks in the domain of the cosecant function. And within those breaks, right, all the numbers are included. So we could say, as we kind of did for tangent, that the domain here would be x is an element of the real numbers, except for x cannot equal what in this case? Well, if I start here at 0, notice if I add a distance of pi, I get to where there's another value not included in the domain. I can do another distance of pi and get another one, another distance of pi and get another one. Or I can go down a distance of pi and get a value not in the domain, go down another one and get a value not in the domain, and so on and so forth. So it looks like, and I know I'm kind of squeezing this in at the bottom here, I'll try to erase this, that for this we could define these as starting at 0 and then adding pi k, meaning adding multiples of pi. But remember, when you have 0 plus anything, that just gives the thing you have, right? So really 0 plus pi k just gives us pi k, would be the domain here. Okay? All right. Okay, so let's do this same process now for secant and cosine. So what I'm going to do here is, first of all, clear out all this mess around here. Okay, and for secant, we need to do 1 over cosine. Okay, because we don't have a button for that. And we'll also graph cosine here. And we see here now is our graph for secant, there in blue. And then our graph for cosine, there in red. And notice, just like with sine and cosecant, where the peaks and valleys of secant lie, they line up with the peaks and valleys of cosine, right? So we see here there's a valley of cosine and a peak of secant, a valley of secant together with a peak of cosine, and so on and so forth. And notice, as I pointed out with cosecant and sine, that here we see that cosine starts right there on the vertical axis, right? Which is what we also see with the secant graph. So that's, again, a way to identify the difference between a secant or a cosecant graph. Okay, now the next thing I want to do is then go a little bit more quickly through finding the domain, range, and period of secant. And again, notice that we see with secant, just like with cosecant, that there's these u's that go up and up forever and down forever, but there's nothing between the values of -1 and 1. So we thus see that the range of secant is -infinity to -1 included, union 1 to infinity. The period, if we again measure the distance over which these patterns are repeating, so we can go from like here, another vertical asymptote here, and then the pattern ends up or finishes repeating there, so it'd be between these values, which if you remember again how we labeled this is -3 pi over 2, this is pi over 2, and the distance between those two is again 2 pi. And then for the domain here, we'll notice in this case, if we start at pi over 2, and then add or subtract lengths of pi, we will get where vertical asymptotes are. Okay. So it looks like for our domain, we can say that it is values of x in the real numbers, but x is not equal to pi over 2 plus multiples of pi, so plus pi k. Okay. All right, that's it for now. Thank you for watching.